Hey everyone, in this lesson about Burp Suite, I'll show you everything that's important and useful for beginners. I'll go over each item in the menu, and we'll use some of its features in practice. Burp Suite is a serious program, and to really learn it, you need more than one video, so I'll be recording this in parts. Let's move on to the installation. I'll be using AirFox, and we'll install the OxyProxy plugin. We'll set it up so the Burp Suite calls it. We're going to grab and intercept things. So let's configure it. Go to Options, and name it Verb Suite here. Here, we'll specify our local host and set port 8080. Exceed it. That's it. We saved it, and now we have it set up. Now, let's install the certificate. You need to open Burp Suite. You can open it from the menu or through the terminal. I'll be using the free version of Burp Suite. Next, we'll go ahead and install the necessary certificate for Burp Suite to function correctly. To begin, please open your browser and head over to the address localhost:8080. Once that page loads, find the link to download the CA certificate and save that file onto your computer. The certificate has been downloaded. Now we need to import it. Go to Settings. Let's get started now. On the process. Import it. All right, we've imported it. Actually, I already had it imported. But you won't see this warning. Now you need to install Docker. I already have Docker installed. All you have to do is confirm and it will be installed for you. So that's it for now. Now, we need to set up the lab where we'll be testing all this. I'll be using G Shop. Note that we're using port 3000. In order to get started and launch this lab, we first need to open a new terminal, enter ifconfig, take the IP address from there and copy it, and paste it into our browser. Specify port 3000. That's it. Our lab has started up. At first, it didn't load for me because I was doing everything too quickly. There's some warnings, let's close them. That's all. Our lab is up and running. It has started. Let me take a moment to tell you all about each and every delicious item that we have available on the menu here today. Each item is very important. Let's start with the first one, dashboard. We have tasks, and here we invite you to please take a moment to scan our website. These are scanners, intruders, attacks, manual tasks, anything like that. We also have ISS active, but it's not here because it's used in about the versions. We don't have the pro version. We have the edition, the free version, and the event log. Here it is. All logs will be tested here. When we work in Purpose View, they will definitely show up here. Well, not just here, but also links and so on will appear here as well. That's it. The dashboard itself doesn't attack, but it controls parallel attacks, meaning intruder plus repeater. The only thing you do is keep an eye on whether you've been blocked or not by the web application firewall. Next, you can see where Burp Suite is getting bogged down with errors. So these are hints for you. So in real work, the dashboard is always running. As soon as we open it, it's running all the time. Now the target. We have a target and we have 3 items. It is built automatically from the proxy traffic. So here's the proxy. Here, hidden IPs, debug endpoints, old versions, and all sorts of IDs are searched for. Examples of attacks are ether, broken access control, meaning an admin endpoint is accessible to a regular user, and business logic, flowers, meaning different responses for different roles. Now let's move on to the scope. Here's the scope. This is needed so we don't attack anything unnecessary. Intruder and scanner. The scanner is available in the Pro version and works only within the scope. For example, so this is some kind of website. We specify here, let's say, I don't know, scope.com, for example, example.com, or our own site that we've opened. This is our lab where basically you can do anything and nothing will happen to us for it. Legally speaking, everything else is ignored, like CDN, AUF, third-party IPs. Without a scope, it's easy to hit the wrong target, so it absolutely must be used. Now, the proxy. In this lesson, we'll be using a specific proxy. And one more tool. This is for manually intercepting requests and responses, so we'll be positioned between the user and the server. We are modify requests and send them back to the server. The other word. These are various types of security attacks. Parameters such as pairing, bypass client, and CSRF, specifically attacks targeting tokens and the replaying of requests, all of this complex activity is effectively handled and managed by the proxy system. Now, the first and second points, HTTP history. This is analysis, meaning we'll have all sorts of IP addresses here. Not lunch, not rice, but domains. So we'll be looking at what it's searching for. This is GWT. Authorized cookies without HTTP. Are the methods put and delete present? So we'll be intercepting all sorts of different methods. These are get, post, put, delete. So get is when we receive something from the server. Post is when we send something to the server. Put is when we change something, like editing a comment, for example. And delete is when we remove something. These are the main methods that are used. What kinds of attacks does this enable? So this is reply attack, request replay, privileged escalation, and mass segment. Now, intruder. What does intruder do? Its main weapon is automation, so the typical attacks are brute force, post, login, like user admin, password. In other words, we'll be targeting specific things, either the login or the password. In this lesson, we'll only be brute forcing the password. Then there's also fuzzing, or bypassing a 403 error, error 403. This means we won't be able to view certain resources on the actual site because they are currently restricted by the system admin or the original developer. It doesn't matter if it's restricted, you can still find a way around it. And then there are cross-site scripting attacks, which essentially means that we'll be injecting malicious JavaScript directly into the target website from. We will transmit the data to the server to carefully verify if there's a potential XSS attack there. Basically, that's it for intruder. Next up, what do we have? We have repeater and decoder, which are used for testing logic, checking authorization, and debugging APIs. For example, again, either GET requests or authorized users. So we can change the ID here, the ID. Authentication bypass, meaning we remove authentication and substitute another user's token. We carry out an attack specifically on that user. Risk condition, meaning we quickly hit send several times. This is to trigger a bug. We'll be causing certain errors on the server, in the session, and so on and so forth. Next, we have the collaborator. It catches blind CSS, as I mentioned, SSRF, XXE vulnerabilities, and command injection, meaning command-based vulnerabilities. Now, as for the server-side request forgery vulnerability, we'll be carefully adding various specific parameters to the link that will definitely trigger a series of errors on that end, unless, of course, the developer has already gone ahead and implemented some very robust input filtering or validation mechanisms. If the server makes a request, SSRF is confirmed. As I previously mentioned regarding link XSS, what we are doing is we actually inject malicious JavaScript code into the target. If after some time, For example, what we entered comes back, then we have an XSS vulnerability. Seventh, this is randomness justing. It analyzes session cookies, RSS tokens, CSRF tokens. Attacks like session, prediction, token brute force, and account takeover. So if we see low entropy, that's critical. The decoder. The name speaks for itself. It's for decoding data. It's often used for JWT, B64, cookies, in other words, base64. This is encryption and URL decoder payloads. For example, with JWT, we change the user password to admin. Base64, we find. Plain text passwords that were encrypted, and Gauzy. Let's look at the compressed response. I'll show this compressed response. It will be intercepted in our proxy requests. If it is, like this. We move on. Number 9 is comparator, meaning to find a difference where it's not visible. For example, damn, with SQL, and in our case, something uses SQL, the responses are almost identical. A microscopic difference in some request. Then there's the modification check. The users and admins' responses are used when you can't see the difference with your eyes, but the server reacts differently. All of this is displayed for us. And 10th, we have the logger, which is technical diagnostics. It's needed when the extension crashes, burp glitches, there's a GVM error, strange behavior, or proxy issues. And we also have an organizer, a pen tester's desktop, used for vulnerability notes, checklists, and reproduction steps. Reports are especially useful for, well, bug hunters. Extensions are enhancements for Burp Suite. That is, these are some custom plugins. For example, checking access control attacks on GWT, advanced fuzzing. Examples of attacks include either GWT or missing authentication headers. And finally, there's Learn. If we click here, then we can go to the Burp Suite website and check out some information there. All right, let's intercept a request. So we need to enable it first. Let's just refresh. Ah, my apologies. Nothing worked out because I didn't select Burp Suite here. I am very sorry about that. Let's go ahead and enable it now, and then we can refresh the page. So now we can see that some requests have been intercepted here. Again, just to repeat, we're in the middle here. And we can see that we have a constant loading process. We can step through this loading process and send it to the server step by step. Here we see that English is set as the language along with some introductory information. Looking at the screen, we can clearly see that we have a GET request, which is located right there on the very first line. Hostname. So as you can see here, that is our specific IP address and the port number. We can also modify requests here and send them to the server. If we change this from E to C, this will mean that instead of English, we are sending a request to the server to switch to Spanish. Now, I'll quickly explain what each of these requests means. So the first one, as I mentioned, is the get method. That's when we get something from the server. Next is the host. That's the IP address, or it could be a domain name. Next comes the user agent, which tells the server which browser we're using to access it. Then there's accept, which shows what method we're using to get information. In this case, we're specifically receiving information now, HTML text. Now, let's take a look at the accept language header. As I mentioned a little bit earlier, here we can clearly see that it is currently set to English, but we actually do not change the language settings right here in this specific section. Instead, we have to change it somewhere else entirely and then send that updated information back to the server if we truly want to get any kind of specific response from the website. Next is accept encoding, which means it tells the server which data compression algorithms the client supports. This allows the server to compress the response, for example, using gzip. Remember, I recently explained what gzip is. By the way, you go ahead and unzip it and take a look at what's inside. Later on, we have connection, which manages network connections. Keep alive means that the client wants to keep the connection to the server open for subsequent requests. This is more efficient than closing it for every request. Next, we have refers, that is, it indicates the URL of the page from which this request was made. In other words, the user is on the application's main page. And cookies, as I already mentioned, we change them here in the cookies. Language. We can change the cookie status if it exists, meaning the cookie's status. This indicates that the user has closed the cookie consent notification and the continue code. Next, we have if modified since, meaning we have a conditional request for retrieval. The client says, send the file only if it has been modified after, and then the date is specified. The given date here is February 16th. If not match, whenever a specific conditional request is made using a unique file version identifier, the client is essentially communicating to the server that it already possesses that exact version of the resource in its local cache. The version of this file, the identifier, we can see it, meaning it's specified here by year. And says, Send the new file only if its current version on the server is different from this one. So we can also substitute certain files. Now let's register on the website. Let's do all this just as an example. I'll show you how it all works. So we can skip each step here and see that the page is reloaded. Right. Is reloading. Right now it's completely down. It'll reload soon. Here we can also drop. Let's stop here and let's register. Well, as you can see, I've already practiced here before recording the video. Let's record the data differently. I am gonna use a password from the numbers 1 through 6. I've entered the password. That is looking great. So now let's go ahead and try to log into your account using your credentials to see if everything is working correctly. Yeah. I'll enter here 1, 2, 3, 4, 5, 6. We can see in the request the login and password are specified. And we can see the method used. It was a post method. So we simply click the login button and successfully sent a new request over to the server. If we completely skip every single step of the entire process, the browser will reload for us. Something's wrong here. It's being specified incorrectly. By the way, we can trigger an error here. For example, we can put a quote here and type something, basically try to log in. And we see that we get object object. So what is this? It's not clear mirror. Object object. We can go here and check the post request. So we're passing something here. Yeah, right here. But it's not clear why. Let's send it to the repeater. And send it again. So you can see that we have some kind of SQLite error here. And here we can keep looking for some vulnerabilities, meaning we have a request. We are sending some kind of specific SQL database request to the end user right here. By the way, this is a very serious vulnerability. SQL injection. We can dig here. We can specify 123 at gmail.com. Right now, I am gonna carefully type in my previous password, which is the exact same one that I was using just before I actually began recording this specific video for you today. Yeah, test 123. And send it. Let's try to log in. We have some kind of error, probably because after I deleted the lab, my data was erased, most likely. All right. Like I was saying just a moment ago, I completely finished and deleted the entire lab environment, so the user account that I had previously created has been successfully removed. So now we are all set and ready to proceed with the next steps. What's Go ahead and submit a specific type of request as well. Here, now that we have everything properly configured and ready to go, let's go ahead and initiate the transmission process to send this specific signal directly over to the signal repeater station located on the hill, ensuring that the message is broadcast clearly and effectively across the entire network for everyone to receive without any further delay or technical interference. That's right, I don't know, say a post request. We see that we triggered an error, but that's not necessarily a vulnerability. Here, we can look at some paths that might help us, ones we can insert. Here, a link. Are there any additional input information we can identify and extract from the error logs provided? Let's try to intercept them again. We see the tokens are being intercepted. The tokens are encrypted, which is good. Ideally, they should change with every request. They can also be decrypted, and there are tools for that in Burp Suite. And as I mentioned before, let's change. Let's say the side language. We can do that here. Try it this way. And check each step. We see that the site is responding somehow. Everything disappeared here. This is an optional vulnerability? As I already said, when we click forward word, we skip every step. Let's do it again. Let's say yes, that is Spanish. Actually, we can also specify the exact post right here. See how the site will behave. We see that we have a post request. Let's change something else here. For example, let's specify localhost here. To view your project in action, you will need to open your preferred web browser and manually enter the local host address followed by the specific port number 8080 into the navigation bar, which will then connect you directly to the development server running locally on your machine for this session. To say it's here, nothing happened to us. It was expected. But in principle, you can still dig around in queries here. They will be sent here to the server and the site will respond. What else would you like to show? Not a decoder, but let's go to the intruder. Let's intercept the login and password. Let me get out of here. Let's try to log in. Yeah, is the login. We can see that here. Our request was intercepted. Let's send it to intruder now. We'll send it to intruder. What does intruder do for us? Intruder's really only needed for one thing. It's used for attacks. As I already mentioned, here we'll only be doing one action, which is brute forcing. So in this lesson, we'll only be doing brute force. Type of attack, type of attacks. We're going to use the sniper attack. Now, I'll explain. There are only four types of attacks. I'll explain each attack now. So, one set of payloads is used. The payload is inserted into one position at a time, and the other parameters stay the same. This allows you to identify a vulnerable parameter or brute force a single field. It's suitable for fuzzing, searching for SQLI, CSS, and also for password brute forcing when the login is known. So it's real important to note. This attack is used if you want to brute force, but only if you know the login. If you don't know the login, this attack isn't suitable. Next, we have VT Ringram attack. It uses a single set of payloads, the same payload. It's inserted into all positions at the same time. So when we don't know either the login or the password, it's used in all positions. All parameters include the same values, which is suitable for simple brute forcing, repeated parameters, and checking for identical values. The third type of attack. Here, each position gets its own set of payloads. Payloads are iterated in parallel by index. The parameter values are logically connected to each other. This is suitable for attacks on login, roles, token ID, and other related parameters. And finally, there's the cluster bomb attack. That is, each position is assigned its own set of payloads. The intruder cycles through all possible combinations of payloads. The number of requests grows rapidly. This is suitable for brute forcing valid data, for parameter enumeration and combinatorial attacks. Only the sniper attack suits our needs. We select it. And then basically what we can do is right-click on the field and select the option to add payload position. After that, we'll enter our password. Will be something like a variable, or we can just select it and click. Add to Avid. Let me do just that. Now, we need to load our login and password here. Our dictionary with logins and passwords. In our case, only with passwords. All right, now let us head over to GitHub. I am going to go ahead and download a specialized word list file that we need for performing the brute forcing attack. Let's download it here to the desktop. All right, we downloaded it. The only change I'm going to make here is this change. Sorry, I downloaded the whole thing. I'm at the page. That's weird. I thought I did everything right. Let's do it a little quicker then. A text document. Let's copy it. Well, since it looks like our password isn't saved here in the system, we'll just have to go ahead and manually type the whole thing in ourselves right now. This is the text of test 1.2.3. All right, test 123 day. And let's save it to the desktop. Let's name it pass. All right, it has officially started, and now we are finally uploading everything. That's it. And we click the button, Start Attack. Pay attention to the status code. The status code doesn't matter, meaning we're only interested in the status code that's equal to 200, only 200. So if we click here, only those will show up there, 200, and we can see that, basically, everything was found. It's also very important to check by size. That's it, we found our password. We can stop our attack now, because otherwise it'll go on for a really long time. We're already using the 50th password out of 1101. So at first we had 1,000 passwords, and I added one more because it wasn't in the file. That's everything I wanted to show. I hope this video helps someone. Sorry that it was so long. I'll record a follow-up about the functionality of ViraSuite. So even a video like this, which could have been recorded faster, still took quite a bit of time. That's all. Thank you all. Goodbye, everyone.